For most, this is where AI begins and ends, an isolated box where you type a question, waiting for an answer. But treating a modern large language model as a conversational chatbot leads to two specific failures. The system remains underused, and it remains improperly governed. Claude operates as a multi-surface execution platform designed to analyze data, write code, and collaborate within existing enterprise environments. To harness a system with this reach, we have to move past prompt engineering and adopt the principles of work design. Work design requires the human operator to define bounded tasks, provide specific source context, and establish strict review points. Moving AI from a single user UI to an integrated enterprise tool requires a total rethink of how the system accesses and interacts with your data. To understand how this works in practice, we will construct the Claude ecosystem from the ground up, starting at its core algorithmic layer and building outward to external enterprise integrations. Without shifting from a chat-centric view to a rigorous architectural model, organizations often lack the visibility and control required to manage autonomous workflows at scale. This diagram illustrates the ecosystem architecture, and at the very center is the underlying AI system, the Claude model family. Raw algorithmic capability cannot be exposed directly to users or enterprise systems without a governing framework in place. That is why the immediate next layer is Anthropic's safety orientation. Driven by constitutional AI, a strict containment architecture is wrapped tightly around the core model. This boundary ensures the model's behavior is aligned and constrained before it ever interacts with external data. Standard user interfaces, like the web application, desktop, and mobile, sit directly on the outside of this containment layer. These surfaces are built for specific, isolated interactions, bounded by the user's immediate session. This architecture treats safety as the operational foundation that dictates all downstream system permissions, rather than a final checklist item. As the platform expands, user behavior must mature across 5 distinct levels of utilization. Level 1 is Ask. This is the beginner baseline, used for manual questioning, summarizing, and brainstorming. Level 2 is Structure. Here, users apply basic constraints, explicitly defining roles, context windows, and expected output formats. By level 3, Reuse, those instructions evolve into persistent projects, skills, and repeatable templates for the entire team. At level 4, the operational boundary moves. As shown on this graph, the system begins running semi-autonomous loops that perform tasks independently. At this stage, you are no longer querying the system. You are handing off bounded, multi-step work for Claude to perform. This degree of autonomy requires level 5, Govern. True delegation demands rigorous governance, including predefined permissions, active system logging, and explicit human approval points. Organizations limited to levels 1 and 2 often leave engineering potential untapped, but moving to level 4 without level 5 governance creates significant enterprise risk. Once an organization reaches the delegation phase, a standard chat interface is structurally insufficient for high-leverage tasks. These complex assignments require specialized surfaces, starting with Claude Cowork for delegated knowledge work. Cowork handles tasks that are too complex for a quick chat, but structured enough to be formally handed off, such as cross-referencing folders of source documents. Success depends on a precise task brief that defines the expected outcome, locks in the specific source files, and establishes the criteria for review. Software engineering tasks are handled through a distinctly different surface, Claude Code. Claude Code is not a sophisticated autocomplete tool. It is an agentic workflow. This flowchart illustrates the continuous loop at the heart of the system. The process begins with an inspection of the existing codebase, followed by a proposed plan and the direct modification of files. The system enters an automated validation phase, running unit tests and fixing failures independently. Human governance remains the final step. The engineer reviews the diffs, with Git acting as a locked safety net requiring a human signal to proceed. High-leverage tasks fail in simple chat interfaces because they lack these rigid operational boundaries. The task brief and continuous test loop make delegation reliable. As the ecosystem expands, Claude must eventually interact with live enterprise systems directly. Custom API integrations demand high developer discipline. including the strict management of keys, logging pipelines, and cost tracking. To manage these integrations securely, Anthropic uses the Model Context Protocol, or MCP. This topology map shows MCP in action. It is the standardized architecture used to expose external tools and data to the AI model through a tightly constrained tunnel. Standard connectors use this logic to bring Claude's capabilities into collaborative workspaces like Microsoft 365 and Slack. On these surfaces, the AI strictly inherits the existing permissions of the host service. This ensures the system enforces tenant-wide consent and honors internal data boundaries, only reading context it has been explicitly granted access to. This leads to the governance parity law. As AI's access to external data increases, requirements for logging and human review must scale in equal proportion. Rigorous permission architecture is the primary enabler of scaled enterprise AI, allowing organizations to integrate these tools with their core data securely. To apply this architecture, we can map a standard weekly task list against these different surfaces. Routine, low-risk tasks, like summarizing a public article, are suited for the standard desktop surface. High-risk, multi-step tasks, like synthesizing sensitive internal documents, demand the structured environment of Claude Cowork. Tasks involving external system manipulation or code-based changes must be moved to highly governed surfaces like Claude Code or secure APIs. Applying this architecture changes the human operator's function. You move from writing creative prompts to validating source context and approving execution. Integrating AI at this scale requires absolute discipline around instructions, data context, and human review. Claude functions as a comprehensive enterprise platform designed to think, build, and govern AI-enabled workflows.